Today we're going to start Unit 4, where we start talking about and using the trigonometric identities. So a trigonometric identity is an equation involving trigonometric functions that is true for all values for which every expression in the equation is defined. The identities help to evaluate functions, simplify expressions, prove identities, and also solve equations. So what we're going to start with is evaluating functions using trig identities. These are something that you do not have to memorize. Even if you were in person for school, you wouldn't have to memorize them. So you're definitely going to want to write these down or print out this paper to have these to reference consistently. I will also add to some of the helpful resources in Canvas. I'll also add a paper with the trig identities listed. So you'll see that quotient identities, we have tangent equals sine over cosine. We have cotangent equals just the reverse of that, cosine over sine. And then the reciprocal identities, those are kind of what we've already been using, because sine is equal to the reciprocal of cosecant. Saying 1 over sine equals cosecant is the same as saying that. So these reciprocal identities are something that we've already kind of talked about with writing trig ratios when we dealt with right triangle trig. The Pythagorean identities, this is what we're going to focus on today. So we have cosine squared plus sine squared equals 1. You could also manipulate this equation. We're going to have to eventually manipulate it somehow. You have tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared, all of that of theta. So something you need to be able to recognize when to use what, when it's going to work for you. So, for example, if you're looking for sine and you're given cosine, you're going to use the first one. But let's say instead of being given cosine, you were given secant and you're looking for sine. You could still use the first one because cosine is equal to 1 over secant. So because of that, above these identities, I'm just kind of going to write like the reciprocals, because if you're given a reciprocal, you could just flip it and use it in the Pythagorean identity. So the reciprocal of cosine is secant, reciprocal of sine, cosecant, tangent, cotangent, secant, cosine, cotangent, tangent, and cosecant sine. So I'm just writing those above it just because I may need to reference using the opposite, like the inverse one. So let's go ahead, and if we look at number 1, we're asked to find the exact value of sine of theta if cosine of theta equals negative 4 over 7. And we're given this condition that theta is between pi over 2 and pi. Well, that pretty much just tells us what sine it's going to be. So I'm going to draw over here, I'm going to draw up above here. So remember when we had the quadrants, we learned back. Quadrant 1, 2, 3, and 4. Well, we know this is 0 degrees, this is 90 degrees, or we can say pi over 2 in terms of radians. Here we have 180 degrees, or pi, and then here we have 3 pi over 2, or 270 degrees. And then back here at 0, we have 2 pi, or we can say 360 degrees. And then we have to remember the signs of each. I remember all students take calculus, meaning all signs are positive in quadrant 1. S stands for students, is sine and cosecant are positive in quadrant 2, everything else negative. Take tangent and cotangent are positive in quadrant 3, everything else negative. And then calculus for cosine and secant are positive in quadrant 4, everything else negative. So we're going to have to reference that at some point. So for number 1, we want to find the exact value of sine if cosine of theta equals negative 4/7. The condition between theta is between pi over 2 and pi. Well, between pi over 2 and pi is in quadrant 2. We're looking for sine. In quadrant 2, sine is positive. So let's just keep note that our final answer should be positive because of that condition. That condition means that sine is positive in that quadrant. That's all it's telling us. So because we're working with sine and cosine, go up to the Pythagorean identities that I said we're going to be working with today. Which one has sine and cosine is that first one. So I'm going to use that first equation, cosine squared theta plus sine squared theta equals 1. If I know at least sine or cosine, I can solve for the missing one. It's like an equation. You're solving for a missing variable. So cosine equals -4/7. So I'm going to say -4/7 in place of cosine squared, because it says squared in the equation, plus sine squared of theta equals 1. When I square -4/7, if you type it in decimals, you need to type parentheses. If you do not, you will miss it. So let me clear what I have going here. All right, so for example, if I type -4 divided by 7 and then I want to square it, that's wrong. A negative square should be a positive. You cannot type it that way. You have to use parentheses with just putting -4/7 in parentheses and then squared, and you get a positive, you get a decimal. Click on that fraction, 16/49, which you could have saw -4 squared is 16, 7 squared is 49. So 16/49 plus sine squared of theta equals 1. In order to continue solving for sine squared, I want to isolate sine by subtracting 16/49. So I'm going to be doing 1 minus 16/49. And I want that in fraction form because I want exact values. So 1 is the same, 1 whole, I want to put it over 49s. Well, 1 whole is 49/49. So 49 minus 16 is going to be 33. So I'm going to end up with getting sine squared of theta equals 33/49. To solve to get rid of the squared, I take the square root of both sides. And the square root of sine squared is just going to be sine of theta, which is what I want to find, equals, I can't take the square root of 33, but I can say the square root of 49, because I can consider this fraction this way. I can consider it as the square root of the top and the square root of the bottom individually. So square root of 49 is 7. So my final answer would be square root of 33/7. And positive based on that condition. Let's go on and look at what number 2 is asking. Number 2 is asking to find the exact value of cosine. So we're dealing with cosine and we're giving cotangent if theta is between 180 and 270. Well, going up here between 180 and 270, that would be in quadrant 3. And we're looking to find cosine. Well, in quadrant 3, cosine is negative. So I'm just going to make note of that. So my final answer should have a negative in front of it. All right, so now I got to figure out which trig identity deals with cosine and cotangent. None of them deal with cosine and cotangent. However, look at what I wrote in orange above them. One of them says cosine and cotangent. So think about it. I can use the second one that says tangent squared plus 1 equals secant squared of theta. Because, tangent squared of theta, sorry. Cotangent, if I want to take that 2/5, if I want to take cotangent of theta equaling 2/5, can I just say that tangent of theta is the reverse of that, which would be 5/2? So because I can say that, I can use, in place of tangent, I can put that 5/2 squared plus 1 equals secant squared. And then I know I'm not solving to find secant, but I know secant is just the reverse of cosine. So 5/2 squared is going to be 25/4 plus 1 equals secant squared of theta. So 25/4 plus 1, well, 1 is equal to 4/4, so that's going to give me 29/4 equals secant squared theta. Finish solving by square rooting both sides. So I will get square root of 29 all over square root of 4 is 2. However, remember, cosine has to be negative, so I know it and secant are negative, so I know the answer is negative, but I found secant, not cosine. So if I want to take, I'm going to go over here. If I say secant of theta equals negative square root of 29/2, that means cosine of theta is the reverse. 2, I can put the negative anywhere with the fraction, negative 2 over square root of 29. That would be my answer for cosine, but I'm not allowed to have radicals in the denominator. So because of that, I would want to rationalize the denominator by multiplying top and bottom by the square root of 29 to end up getting negative 2 square root of 29 all over any radical times itself is that number without the radical. So all over 29. Whoops. So my final answer for number 2, cosine of theta equals negative 2 radical 29 all over 29. So that goes with number 2.